Today we're going to be looking at a very brief overview of trig as well as looking at vectors. First thing we need to look at, physics deals with triangles all of the time, and for the most part they're always right triangles. Let's look at how to label a right triangle. The first thing we need to identify is where that right angle exists and mark it. I have that right angle marked, and the side that is opposite of the right angle we call the hypotenuse. The other angles we're interested in we mark with an arc, and we label those with a Greek letter theta. Theta, T-H-E-T-A is how we spell it using English. And we can label the other two sides once we know which angle we're interested in. Scientists, mathematicians, they're really creative when they name things. The side that is opposite of the angle or opposite of theta we call the opposite. The side that is connected to it or beside it we call the adjacent. Now let's take a look at vectors. Vectors are measurements or quantities that have both magnitude, and we can think of that as how much, and a direction. And we represent those by arrows and angles. So we can see here an arrow. Now you'll also notice this part right here. This helps us get our reference angle. If we don't have a full coordinate system labeled, that's what we do to show where our reference angle is. Magnitude we can think of as how much. So one example would be a displacement of 23 meters. That would be our magnitude. That would be how much displacement we have. And then the angle, we have an angle, again represented by theta, of 21 degrees. Let's take a look at how to find different components or different pieces of those vectors. Because we can treat things as right triangles, there's a brief mnemonic we can use called SOHCAHTOA. And this involves the three trig functions, sine, cosine, and tangent. When we have the sine of the angle, or the sine of theta, it is equal to the opposite, which if you look at our mnemonic is an O, divided by the hypotenuse, which is the H. So the sine of the angle equals the opposite over the hypotenuse. We also have the cosine. The cosine of theta, or the C, is equal to the adjacent, which we give the A, divided by the hypotenuse. Again, cosine of theta is the adjacent over the hypotenuse. And the last one we're going to look at is the tangent. The tangent of theta is equal to the opposite over the adjacent. So we have all three components combined in different ways to get three different ways of relating the angle. And this is just a visual guide here for you for SOHCAHTOA. Go ahead and pause the video here, take a second, and sketch this into your notes. Let's take a look at how we can calculate these. We're going to calculate the vertical and the horizontal components of the following vector. I have a vector with a magnitude of 56 meters and an angle of 40 degrees. The first thing I need to do is draw each of the components. So I'm going to draw an arrow that is the same amount to the right as my total vector. And then I'm also going to draw an arrow up that is the same length as the total up of my overall vector. So you notice now that creates a right triangle. So I have a right triangle and two different sides. Using my reference angle, what I've drawn in blue would be my opposite. So this would be the opposite, or sometimes we refer to the opposite side as the sine component. The component that I drew in red is adjacent, and a lot of times we will refer to the adjacent as the cosine component. Let's take a look at the calculation. We're going to start with the vertical component, or the sine component. Because it involves the opposite, we have to use the sine of the angle. So the sine of theta is equal to the opposite over the hypotenuse. I'm going to do a little bit of algebra here first, because the opposite is the side I'm interested in. I'm going to multiply both sides by the hypotenuse to get it to cancel on the right side and get the opposite by itself. So hypotenuse has canceled, and I'm left with the hypotenuse times the sine of the angle equals the opposite. Opposite, or the sine component, is the one I'm interested in here for the vertical. Then I can plug in my numbers. I have 56 meters times the sine of 40 degrees. Check to make sure your calculator is in degree mode here. If it's not, you want to make sure you put it in degree mode, because you'll get weird numbers if you keep it in radians. When we plug this in our calculator and we round it to 2 sig figs, we get a component that is 36 meters. So this vertical component, this blue component, is 36 meters. Now let's take a look at the horizontal component. Again, we're looking at the cosine component this time. So we use the cosine of theta is equal to the adjacent times the hypotenuse. Just like the vertical component, I want to multiply both sides by the hypotenuse to get it to cancel, because I'm interested in the adjacent. So hypotenuse has canceled, and I get the hypotenuse times the cosine of the angle equals the adjacent. Plug in my numbers. I have 56 meters times the cosine of 40. Again, make sure your calculator is in degree. When we round it to 2 sig figs, we get 43 meters. So this component is 43 meters. The last thing we want to do is a sense check. Does this make sense? Well, 45 is a mid-angle. 45 is the one where both components are equal. Looking at this, my angle is less than 45, which means my vertical will be slightly less than my horizontal. So this makes sense. Now it's your turn to try. We're going to again calculate the vertical and the horizontal components of the following vector. Here is the vector we're going to calculate. Now this one, I am going to point out really quickly, the angle we're referencing is this angle right in here. Pause the video here, give this a shot, and see what you can come up with. Okay, how'd you do on this? First thing again, we want to draw our two components. My vertical component is this one right here, match that length. And my horizontal component is matching the length this way. And looking at it, this time my vertical component is adjacent, so it's going to be my cosine component. And my horizontal is opposite, so it's going to be my sine component. So this time my calculations will be a little bit different because I'm calculating in different directions. So for my vertical component, I'm going to use the cosine equation because it's adjacent to my angle. Do my algebra, plug in the numbers. I get 83 newtons times the cosine of 15 degrees. That'll give me my adjacent, round to 2 sig figs, and I get 80 newtons. For the horizontal component, it's the sine component, so I'm going to use the sine equals opposite over hypotenuse. Do my algebra, plug in the numbers. 83 newtons times the sine of 15 degrees gives me 21 newtons. We do our sense check. Because my angle is 15, it's pretty far from 45, so one length is going to have to be much longer than the other. Excuse me. And I see that with a vertical component 80 and a horizontal component of 21. So this does make sense. Good luck. Work toward your practice problems. If you have questions or need help, please feel free to reach out.